Welcome back to our grade 10 maths lessons. I'm Miss Awinup, your maths teacher. In our last lesson, we looked at the remainder theorem and the factor theorem, okay? In today's lesson, we are going to look at solving polynomials, okay? Let's see. Solving polynomials. Now, when we are solving polynomials, the idea is very similar to when we are solving quadratic equations, okay? Now, in order to solve polynomials, we must first factorize, okay? And we've done this when we looked at solving quadratic equations, okay? The idea is the same. Now, how do we use the factor theorem and the remainder theorem to help us factorize and then solve a polynomial? Okay, we're going to do that today. Let's have a look at the example we used in our last lesson, okay, where we had the function of x equal to, let's see, x cubed, cubic polynomial, all right, minus 4x squared, minus 7x plus 10, okay, and we identified the polynomial or linear polynomial x minus 1, okay, divided by, all right, and we found that x minus 1 is a factor of the function x cubed minus 4x squared minus 7x plus 10, okay. Now, in order to factorize this polynomial, we are going to use the quadratic that we found, all right, after dividing x cubed minus 4x squared minus 7x plus 10 into this linear polynomial, all right. So we found that the quadratic was x squared minus 3x minus 10, okay. So this is the example that we used in our last lesson. When the function of x is x cubed minus 4x squared minus 7x plus 10 is divided by x minus 1, we have an answer x squared minus 3x minus 10, okay? So there were no remainders, which means this was a factor. So our factors are x minus 1 and x squared minus 3x minus 10. Now, we cannot find the value of x when we have a quadratic factor like this. We must factorize the quadratic so that we have linear factors like this one here, okay? So we've learned this already. We need to find all factors of negative 10. That will be or will give us a sum of negative 3. Now, those factors are negative 5 and positive 2. Negative 5 plus positive 2 will give us negative 3, okay? So, x minus 1 is equal to, x minus 1 and the factors of x squared minus 3x minus 10. We have x minus 5 and x plus 2. So we have completely factorized the function x cubed minus 4x squared minus 7x plus 10. Okay? Once we have identified our linear factors, in order to solve the equation, we need to apply, okay, the null factor law. And like I said previously, you've already learned the null factor law in solving quadratic equations, okay? So what do we do in the null factor law? We make all these factors equal to 0, okay? So let's see, x minus 1, all right, is equal to 0. X is therefore equal to 1, okay? Then we have x minus 5 equal to 0. We have x equal to positive 5. And the last factor, which is x plus 2 equal to 0. X is therefore equal to -2. Okay, so for any polynomial, all right, with a degree of 3 and more, we find that there are 3 solutions of x, or there are 3 values that are equal to x. Now, why is this? Unfortunately, we're not going to look at graphs, but I will show you a rough sketch of why there are 3 solutions, okay? Now, you have your Cartesian plane. Remember, the value of x is the x-intercept of the graph. So we have one intercept at +1, all right? Let's draw this properly, 4 and 5. You have another intercept at +5, and you have one intercept at -2. Now, because this is a rough sketch, I will not show you turning point or whatever. I'll just show you where your x-intercepts are. So the first one is at -2, so your graph is going to cut -2 here. We'll turn around at some point, cut +1, we'll turn at some point here, and then cut through +5. Okay, so this is an example of how a polynomial function will look when you sketch the graph. Okay, there are 3 solutions of x, meaning there are 3 x-intercepts. Okay, I hope you have learned something new. Of course, it is a review of factorizing quadratics, which we've already seen, and applying the null factor law to find the value of x. Okay, I hope you've enjoyed this lesson. I'll see you in the next lesson where we will look at inequalities.